Here you go.
No, this is how you work. This is how you work it. No, wait, no. Okay, so the person that breaks it, and the person that does not break it gets to choose. Oh, and then it makes it equal. Have you ever heard that? So like, if you're gonna break this, I'll break it into
okay.
two parts because it keeps the one person from breaking it into like a super large piece.
We have a bunch of stuff to do today in terms of just getting ready for Thursday. Also, I'd like to do a little reviewing stuff for part of Thursday also. And so the first one we're going to do, maybe we'll do a couple of those. Today's stuff in terms of finding lengths of arc lengths. Now, oh, were you asking about?
Well, like number 7. Like
Okay.
5 or
Okay. Did you get 8 or 9? Did you get 9?
Or 7?
Didn't I?
You assigned 5, 6, 7, 11, and 13.
Yeah, let's go over
Yeah,
some
that's
of
the
that.
That's the truth, Mr. Kramer.
Yeah, okay. Okay, that gives me a fit.
Oh.
Because I wanted 9 on the test. So I'll have to rewrite that.
Good idea.
Okay? Then, okay.
How do you solve them when they don't?
Okay, we'll look at 7 first. Okay, here we go.
Has it ever occurred to anybody that just animate this whole section in mathematics?
Mr. Kramer, I have no doubt Mr. Kramer goes through
But number 6, 7.
Mr. Kramer,
Yes,
could you write a math book if you wanted to?
I don't know if I would want to, but yeah.
What are we doing?
Some books. Okay, now.
Right on top.
Number 6.
Thank you. Okay. You know how to find length. And length is equal to the integral from a to b of the square root of 1 plus the first derivative of your function squared dx. Okay? So, first thing we're going to do here is find the first derivative, which is a nice way to do a little reviewing. So, y prime is equal to what? What's the derivative of this?
3 halves x squared plus 3 halves minus a half.
And then
Over 3 and 2x.
Okay, and 2x.
That's 1/2.
Okay?
Wait, where'd you 2x?
That's inside. Chain rule. Okay? So this goes out, this goes out, this goes out, and this goes out.
Whoa.
And at this point, this is what it simplifies into. Times x squared plus 2 to the 1/2. Okay? Now, I'm going to give you x prime squared, because we need that right over here. And that's going to give me x squared times x squared plus 2, period. Which gives me x to the 4th plus 2x squared. Okay, so now, here I go. I'm going to go from 0 to 1. And I have here in the inside
yeah, you do that, and then you put it in the square root, and then you find then you can factor it.
Yeah.
okay? And now this is a perfect square. Okay? Because that is going to be x squared plus 1 quantity squared is what we have underneath here. Okay? And so now we're going to go, I can do that, 0 to 1 with x squared plus 1 dx. Okay? So, now the antiderivative of this is x to the over 3 plus x evaluated from 0 to 1. So it's going to be
4/3.
1/3 plus 1, and so it's 4/3. Yes?
Can you do number 6 now?
Number 6 now.
Right now.
Okay,
Right
and,
now.
ooh. I am so disappointed that I didn't assign
You can put number 7 on the test.
Yeah.
Yeah, that's a good idea.
Indeed. Which one are you talking
You
about,
can put
Brianna?
number 7 on the test instead of number
But
9.
she said
But
you
I need
need-
to do number
I think
6.
number 3.
Did I assign 6?
Yes.
Okay,
I understand this.
here we go. And see, I don't have that one circled in my book, so this might be an experience. 3 ln of x minus x squared over 24, and we're gonna do 1 to 6, here we go. And we know where we're going in terms of what we have to do in terms of the formula in a minute. So the first thing we want to do is find the derivative of this.
3 over x.
Okay, 3 over x, that's this one,
Minus x over 12.
minus
X over 7.
X over 12.
x over 12. Okay, and now I'm going to square this. And thanks for helping me here. I like this one now. This is going to be okay, I think. I hope. Okay, so this is going to give me 9 over
9
x
over x
squared
minus x.
minus 2 times 3 over x times x over 12, right? Middle term?
1/2.
Plus
Oh, it's okay.
x squared over 144.
Yep.
Okay, and what does this turn out to be?
1/2.
Okay, this is a 1/2. Okay, here we go. Now watch what happens. That's why that. Now I'm happy that this is just as good as 9. Okay, now here we go. We're going to go from 1 to 6. We're going to go to the square root of 1 plus 9 over x squared minus 1/2 plus x squared over 144. Okay, now, dx back here.
So then you
Now,
have
notice
x over 12.
1 minus 1/2 is going to be a plus 1/2, right?
Yep.
So now this is out of here, and you notice that's a perfect square.
3 over x plus.
So this is going to be actually 3 over x plus now x over 12 quantity squared. But I have the square root of that, so this turns into now 1 to 6 of 3 over x plus x over 12 dx. Period.
Right.
What happened to your 1/2?
This half here?
This half?
Now I noticed, see, you kind of have to, you're going to be working backwards a minute. Over here, look what I had here. You see this? Now it's a minus, and that turned into a minus 1/2 in here. Did you see that minus 1/2 here? Okay, then I had 1 minus 1/2, so that's a plus 1/2. So now I just said, it's almost like this one. Instead of a minus, it has a plus. You didn't see that, did you?
I see that it's like almost exactly the same, but where does the 1/2 go from to the next step?
Oh,
Don't you still need it in there?
no, okay. I want to show you that this is this. And that was a really fast for me,
Oh, you took it out of, okay.
but let me do it anyway, so everybody sees it. If I square this, I get 9 over x squared plus 2 times this term, times the term over here, x over 12, and then I have plus x squared over 144. This number here is a half. Okay? Is that cool? Yeah, crazy is kind of right. Okay, now, I think you can take it the rest of the way, right?
On the antiderivative and plug in them.
Yeah. Any questions about that?
With the, okay,
Can you do
with
the
x,
antiderivative?
Can you do the antiderivative of just like the 3x?
Oh,
3 over
this
x?
here is 3. I just usually write this on the side like this. And when I go after I derive this is all I can help myself. I get a minus 1 times 3 x to the minus 2. So it's a minus 3 over x squared. Okay?
No, it'd have to be x to the 0.
Yeah.
Oh, you can't have an x to the 0.
I
It does
know.
not exist.
So what do you do?
Isn't x to the 0 just?
I will tell you pretty soon. I have it, we have done it, and I intend to get there yet today.
Yeah, but if aren't you finding the antiderivative?
I'm finding the antiderivative,
Yeah.
and then you go,
You drop it down one to -2.
Yeah, don't you
You
add?
go up
oh,
one.
just a second degrees, just a second
You have
degrees.
to add it.
You've got to add, oopsie, oopsie, oopsie. I was led astray here. This here is actually 3 over x, and its antiderivative is 3 ln of x.
Right.
Okay.
Okay? Oops, oops, oops. Like it even more now. And, okay, now,
So that one, arc length rule isn't like necessarily correct, where you just have f of x derivative squared and then you just plug in the number. That's all you do.
yeah, all, you see how much it is, all that means, yeah.
Yeah.
Yeah, yeah.
Why is it absolute value? That's.
Oh, that's a big topic.
Let's
It goes this way. When I do, this here is ln of x.
What did you?
Okay, now,
Here. Third Wednesday night.
this is, I'm going to try to do this fast. This is ln of a negative x, like that, going that way. And when I take a derivative, just to do it quickly, the derivative of that is 1 over x, provided that x is positive. Okay, now on this side, you'll notice x is going to be a negative. A negative, okay, I'm still doing this, x is positive on this side, here like this. Okay. You notice this slope here is 1 over x, these are positive numbers, these are negative slopes. And when I take this one, there would be 1 over a negative x, just a second. And x is positive, so this would be negative, and it has to be absolute valued this way. That's not a very good explanation. But it does come, and I have given it way back some time ago. I should have a better explanation quickly. I don't have it. Yes?
Are we going to need to prove the arc length?
Are we able to prove that? No.
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 Not like we did yesterday?
No,
Okay.
no. It's a wonderful little developing it, and I did it because otherwise you think, what in the world is that crazy thing doing? Why are you integrating and differentiating all the same problem? Okay, now, a few other things that we need to do today, a whole bunch of things. But you asked a few questions yesterday. On 17, 23, and 24, do you need any one of those in particular
Which page?
Which one?
of what we did yesterday?
6.3.
Yeah.
But you,
6.3.
I can do all of them, but I'd prefer not to do all of them if I don't have to.
can you list off the numbers just again?
There 17, 23, and 24, and that's on page,
400 and 401.
You
yeah.
didn't assign those for yesterday.
No, they were a couple days ago, and a couple people had trouble on them.
17.
Page 400. 17.
Yes.
Okay, let's do 17, and so here we go. We have a very nice little curve here like this, and you've seen this thing before, and this is y equals e to the negative x. Okay? And we're going to rotate this thing around the x-axis, and we're going to go from 0 over here to ln of 4, I think. Yes. Okay? Now, to do this, we're going to go around, and so I'm going to go around this way, and we're going to make these discs. Okay? And this is going to be delta x, and so my derivative, they're going to go all the way around. So I have these kind of discs like this all the way through. The thickness is delta x, or dx, Okay, so this is the thickness, and this length is the radius, which is this. This is the radius all the way through. I have to square that and multiply it by pi, and do this from 2 ln of 4. Okay? Now, that's the big stuff. Now we just have to crank it up. Yes?
And like, would it be like minus 0, just like if minus 0 squared to 0, y is equal to 0 is the other equation, right?
I didn't follow that. Try it once again.
Okay, so like if there was another equation, but since the equation is y is equal to 0, like the second equation, the bottom equation is y is equal to 0, you don't put it in there, because it's just 0.
Okay, okay, here. This squared becomes, I'll take the pi out like this, and we're still going to go 0 to ln of 4, and this is going to be e to the negative 2x dx. Okay, the antiderivative of that is going to be pi, and we're going to have here, the antiderivative of that is e to the negative 2x over what?
Over negative 2.
Over negative 2. Like that, right?
Yeah.
0 to ln of 4.
Okay.
Now that's even a little challenging.
That's
So-
not very nice.
Pardon?
Not very nice.
Not bad. I think I'll doodle some up here. In fact, I'll doodle up there right now. A minus 2 down here. What does this look like? That's e to the negative 2 ln of 4,
Yeah.
which is e to the ln of 4 to the negative 2,
Yeah.
which is equal to e to the ln of 1 over 16, which is equal to 1 over 16.
All right.
Okay? So this is 1 over 16. Okay?
Okay.
And, oh, that's all. Boom, we'll do it this way. And then the next part is going to be minus, and then put a 0 in here. That's a 0. That's a 1. So it's going to be plus a half.
All right.
Okay? Yeah.
So, for like 18, all of this is just cosine x, pi cosine x squared from 0 to pi halves.
Which one are you talking about?
Like 18. So all it would be is my integral from 0 to pi halves,
Yeah.
and then pi cosine x squared dx.
Mm-hmm.
Okay.
Mm-hmm. Yep. Okay, any other questions on this? Kinza? Okay, yes,
Is 6.7 on Thursday's test?
6.7, which we were talking about today.
Yes.
No.
Is that assignment due Thursday or is it due Friday?
Yeah.
Please,
Let's just.
Friday?
With as many people are out today, Friday's fine.
Okay.
But you're gonna find out you know everything in that chapter anyway. Okay? Everything we're going to do on that, we're going to know. Okay, hey, I'm doing really well as far as time. Do you need anything else in terms of areas, volumes? We're going to be mainly doing volumes and lengths of arcs. Yes,
So test is 6.2, 6.3, and 6.5.
forget 6.2.
Okay.
Really?
That's
So just 6.3 and 6.5.
All right.
So is it a quiz or is it a test?
What?
Is it a quiz or is it?
It's a test.
So 6.3 and 6.5?
Yes, I am.
Yes.
Okay,
Could you do 24?
24. Okay, now, okay. The unfortunate part of attending school, whether here or college, is you generally do not get to use technology on these. It almost never happens. And I'm finding even in the engineering department, they don't want you to use the technology very quickly. They're really slow about throwing that in. And I think with very good reason, okay? But now, this book has a number of places, and here's one where it doesn't, okay? And so, we're going to just, all we have to do is set it up, and it really gets set up pretty fast, I think. 20, you said 20?
24.
24, okay? So we got this nice little curve like this.
401.
And this nice little straight line that goes this way. And we're going to go around. Here. Okay? Now, here are my sums. And so this one's on the top. And I'll go from there all the way here. And then take take away the center. First I'll go way out here, and then take away the center away. So, here we go. I'm going to go, and this problem does not tell me where this point is. Okay? And so we gotta find that in a minute. And that gives me 2x equals 16x to the 14th. You can see 0, 0 is going to be a solution.
It's the 1/4.
Pardon?
It should be x to the 1/4, not
Yeah.
14.
Yeah.
It's x to the 1/4 raised to the power.
Thank you. Okay, now, I'm going to simplify this a minute.
Yep.
Okay? And then what I'm going to do is divide both sides by x to the 1/4. Oh, this is cool. Can anybody tell me what x is?
No.
Okay, you'll get it in a minute. This gives me x to the 3/4, right?
Yeah, I suppose.
Equals
8.
8.
2.
Okay,
26?
it's going to be 16.
Oh,
Because now I'm going to take the 4/3 power of each side. And I get here x, that's here. And the cubed root of 8 is 2. To the 4th is 16.
that's neat.
Okay.
Okay, so 0 to 16.
Yeah.
Okay, now, see, that's part of setting this problem up. And then this is going to be the top. I'll put a pi out here, is that right?
Yep.
And then I'm going to square each of these units. And this is the top, so that's going to be 16 squared is 256, I believe. X to the
1 half.
1/2 minus
4x.
4x squared dx.
Okay.
Which is interesting here. Oh,
How did you get the 256x?
And a derivative of x.
squared this number.
I took the derivative of it.
Okay?
All you did was square.
Why do you do 1/2?
It's like 1/4
1/4
squared.
Okay,
1/4 times 2.
there it's set up. Okay, the next thing I'll do, come along with me for a little while in terms of review. And I would like to do some exponential stuff because I wanted to show you once again yet the idea of E playing out for us. Oh, yes,
Are you gonna have a y 3 months something?
yes, sir, I am. There will be one.
So with the y, you just have to set the equation equal to x, correct? And then you go from like 0, like on the y-axis and set that.
Exactly.
Okay.
Yep, there will be one like that. Okay, will you go with me to page 434? 434. And I just want to talk about that just for a moment because I think you know how to do all that stuff on that page. And you'll notice it's entitled Revisited. Okay?
Where?
Page 434.
Yeah.
Okay? Let's start by looking at the function here, which is the natural logarithm, which goes this way. Okay? Now, it says that the domain of this thing goes from 0 to infinity, this way, and 0 is not included. Okay? That's the domain. The range is everything.
Are you looking at theorem 6.4?
Yes, I am.
Just something we'll need to prove.
Okay? And now the next, number 2, guys, you're taking too much time and you're talking through it. Number 2 I'll talk about later. Number 3, you see how nice that one goes? ln of x times y is into like this. Any questions about that kind of stuff? Okay, and then the division one is next. And then this great one here, x2, and I think he uses p there, is this one. And you are very aware of what's there, right?
Yeah.
Okay, then he has the derivative and the integral. And a while ago, Hope was asking about number 6. And I'll try to get a good explanation of that one tomorrow, or Thursday. If I remember, I hope I do. Okay, now what's this? L dx of ln of x. What's that equal to? What's the derivative of
1 over x.
1 over x. Now you notice there that he doesn't do it quite that way. He has function notation here. And he does that for this reason. D dx, what would this be if this would be a 2x here? Like that.
Maybe 2.
1 over 2x.
2 over x.
Okay, so it's 1 over
2x.
1 over 2x times 2.
2. Oh, yeah.
So that's going to be 1 over x.
Oh.
That's fine.
Okay? Now, just, he has other built in there. You will get a problem where that's not going to be so simple as just a 2. Yes?
So if you have like ln of x times, like x times, no, not x squared, just x times a different number, is it always 1 over x?
Yes. Okay, now, let me prove that to you.
Times
This,
that number.
this statement here could be like this, dx, and that statement is going to be ln of x plus ln of 2.
Oh, yeah.
And this is a number. And so the derivative of the number is always 0. Okay?
What about, what would be a derivative of one where it's x to the something
Squared.
again?
Okay, like this.
X to the third.
Okay, now, I can write that out very,
Is it 3 over x?
Or would it be like 1 over x?
okay, yeah, well, DeVries, where's your mind going on this one?
Well, I moved the 3 over to the third.
You put it in front?
Yeah.
Okay, now DeVries is going to go this way. And you don't have to go there, but it's a pretty smart way to go. Now we have this, okay? Now, we can figure out this derivative very fast. That's going to be 3 over x, right? Okay, but now let's do this one, the other way. And that's how it's written in the book. You take this, it's going to be 1 over x cubed times what? 3x squared.
Oh.
See? And that's the same as this, right?
Yeah.
Okay? See how all that stuff fits? Now, the next one I want to do here, in just in terms of a quick review, is the last one. What about the integral, which we had just a few minutes ago? Dx, like this. Okay? And that's going to be ln, and we use absolute value because we use x's can be positive or negative. And you notice we define the derivative, or the integral for just the positives. But this will work flipping it over the axis. So we'll go the other side too. Now let me show you something else. I have number 11 circled. Let's go to problem 11 a minute. And we have this. Just wanted to show you this technique. We have this. And how do you deal with it? 0 to 3 dx. This is how you deal with it. You take this thing and you divide this into the top. X plus 1 into 2x minus 1. How many times did I go into there?
1.
It goes 2 times. You get 2x plus 2, and what's my remainder? Negative 3. I've got to subtract. A minus 1 minus 2 is minus 3. So, this turns into 2 minus 3 over x plus 1, right?
Yeah.
Okay, now you're saying yeah, but we have to do some algebra 2 a minute. What happens if I want this as a common denominator, which I have up here? Is this the same as this? Well, if I'm going to do a common denominator, now I'm just doing extra stuff. You certainly don't have to do this if you know what you're doing. I'm going to make a common denominator here like this. Is that okay? See,
Yeah.
right here? And then this is going to be minus 3 over x plus 1. Okay? Now we have a common denominator. What does this turn into? 2x plus 2 minus 3 is?
2x minus 1.
Okay? Okay? So are you convinced now that this thing is just like this?
Yeah.
Okay? Oh, let me just, we're going to worry about this back here. Okay, now look at this. Look how easy this is. what is the antiderivative of this?
2x.
X squared.
2x. Okay, what's the antiderivative of that? Minus ln 3 ln
X
of
plus.
the absolute value of x plus 1.
Oh, that was nice.
See? And now you put it from 0 to 3.
Oh. Oh, question.
Yeah.
So like on 7, can you just change it to ln of x to the 4th?
Where are you? 7?
Yeah. Can you move that x back over there?
Can you move it? No, you. Yes, you can.
So it's just ln of x to the 4th.
No. No.
So can you do
No. You're looking at 7?
Yeah. Or how would you find that one then?
Okay. X
it says evaluate
3
for x is equal to
ln
1.
of x, like
Yeah, you
this.
have to find the derivative first.
No, because that is the derivative of it.
Oh, so you just put a 1 in
So
there.
don't you just put 1 in?
Yeah. And
3 over x.
So the answer is 0.
well, we haven't found the derivative of this yet.
Even though it says d over dx.
There's no.
Well, that says, okay, look at here. It says this. We've just done this part.
Give me a fun
And
name.
now x equals 1.
Yeah.
What's the derivative of this?
Okay.
Now this is again review. This is why we're doing it. There's
One.
it's located right here, right?
One
First times the
three over
derivative
x.
of the second.
Yeah.
So this is going to be x times 1 over
3
x
over x.
plus 1 times ln of x. Evaluated at x equals 1.
3.
And so
What
this
is the
is
x to the third? Oh, no.
3
times
3 plus ln of
3
This ain't helping us.
Woo!
Shouldn't there be a 3?
where?
Okay, yeah, that's 3 ln of x. So when you took the derivative of x times.
This is number 7.
Yeah, right there. Shouldn't that be a 3 ln of x?
Yeah.
Instead of a plus 1?
Oh,
Stop, baby.
1. This is the 1 times. Yeah, there should be a 3 here.
Okay.
But okay.
It doesn't make a difference.
Well, yes, it's. If I were correcting it, I might be able to notice it. Okay, even though you get the same answer. Okay? Now, yes,
Can you do that one again?
pardon?
Can you do that again?
Sure. Maybe I'd like to try doing it a different way. Yeah, I'd like to do it differently. Okay? This is cool. Let's do it in a different fashion so you can see it done again. Although this is I prefer this way to do it. We have here x times ln of x cubed, and I want to find its derivative. Okay, so I find it like this. And so I'll go the first times the derivative of the second, which is 1 over x cubed times the inside, which is 3x squared, plus the first times the derivative of the second, like this, and then evaluate it at x equals 1. Now those is functioning very differently within integrals, okay? And so now I just put a 1 in here, so those are all 1s, so that's just a 3. Oh, isn't that nice? And that's a 0.
Does he not want us to evaluate 8 and 9? He just wants the derivative then?
He just wants to and like 8 we've done before.
So 8 just finding ln of 1 over x?
Okay, hey, we're moving very nicely, but I'd like to cover a couple other things yet today. And of the same variety. So here we go. This is on page 436. 436. Okay, now, okay, I'm going to finish my sentence in a minute. That goes you back all the way to probably first semester of Algebra 2, where we start. Yes?
Okay, so number 8.
Okay, just a second. You guys are getting, okay, number 8.
I really don't know how to do it.
Okay, here we go. Yes, you do.
No, we.
And I'll show you how. It looks so terribly hard, and it isn't all that difficult at this point. And we're going to find the derivative of this. Okay, now, watch what happens here. What is the derivative of it if my finger were an x?
1 over x.
Okay, so this is going to be 1 over ln of x. Now, times what's the derivative of that?
It's
So
just
here's the
you.
answer.
1 over 1 over x.
Over x, no.
Wow.
Yeah.
Combine those 'cause they're not-
How?
See, that's why, you know,
Oh,
you guys are really sharp,
So is that all?
but there's just so much stuff,
I'm actually.
okay? Yes.
Really
Is that all
smart.
we need for that answer? 'Cause it
Yeah.
doesn't give
My
you-
doctor says that's
Yes.
an IQ.
So where is the absolute value?
Guys back there,
Where's
sorry
the
to hear.
absolute value come in this case since you didn't take the internship?
Because I can use positive and negative numbers.
So you just always do that?
Yes, yes, you do. Okay, now, hey, I have 5 minutes, so I wanna keep rolling here for just a minute. Thanks for the disruption there, though, that was okay. It doesn't take as long.
Glad I could help.
Property, thank you. Theorem 6.5. Notice the first one. The exponents, you see those first three. Does anybody have any questions about those first three? On page 436.
No.
Okay, this is my function. And I always think this is one of the great gifts of God to mathematics, especially of higher level, because it is so easy. So you got all those exponentials. Okay? Now, 4 and 5 are very easy for me, but they weren't the first couple times I worked with them. And I think you do get along with them better than I did. The first one is this. ln of e to the x. And that is nothing more than x because we got these e and ln are inverses of each other. Okay? And kind of. But you also notice this rule. This one is always the easiest part because it's going to be dumped over here. This is ln of e, and we know ln of e is always 1. So that one is nice. The next one is even more important. That is e to the ln of x, like this, is equal to x. For x greater than 0. Okay? Now, couple other things here. At the bottom of the page, we do both the derivative of it. See, here's the derivative, d dx of e to the x is itself, but what happens if we had x squared?
2x.
Okay, that's e to the x squared times 2x. Okay? Now, what happens when I take the integral of it? And that's at the bottom of the page. The first one is kind of easy. Where does he go? No, he doesn't go any further than that. Okay? So I'll just let that be for a moment. And then I'd like to go to theorem 6.7. 6.7. Now, Kramer, can you remember how to do this quickly? Now we're going to have this be, oh, do I want to go up earlier than that? Yes. I would like to go here.
You don't have
Hey guys, I will come back there. We have worked very hard. Yes, Derek.
So what was the antiderivative of 11?